Hi, now we are going to see an example of a generalization. What we are going to do is basically make an stack generalization algorithm that corresponds to a type of generalization, which basically takes some models, some submodels, and takes their predictions to make a new prediction. So here we're going to have an example to see how it works. First, we implement some basic libraries, which everybody knows, and now we need to load our our file of the dataset. The dataset that we are going to use is from the UCI machine learning repository. That is basically the data taken from a sonar that what it does is to try to classificate between mines and rocks. Um, so all the variables are continuous and generally between the range of between 0 and 1 and have an output, a string output, which is M for metal or R for rock. Here we can see the database. As we can see here, there are a lot of the records between 0 and 1, like I said, and finally it has the string that says is if it is a rock, and here we have some metals. So well, that's what this method does. Here we have the link for the repository. Next, we need to treat our dataset, so we are going to make columns from each of the measures and uh, convert the string of the M and the R for for a 1 and a 0, because this is a classification problem like we did with the spam problem that we have in class that we had in class. Um, Next, with this method, we divide the data in the train and the validation datasets. This is a method to calculate the accuracy of our predictions that we are going to use further. Um, Now we have, well, this is the method that evaluates the algorithm used using this accuracy metric method. Now we are going to actually start to make our machine learning algorithms. So basically, this is the procedure. We have first to implement the first model that will be the KNN, the K nearest neighbors. The second model will be the perceptron, and finally the aggregated model, which is going to use logistic regression based on the previous two predictions of the two models and make a new prediction. First, we have the key nearest neighbor model that basically needs to calculate to get the Euclidean distance, next gate neighbors, and finally this is the method that use the prediction using this model to get our results. Um, Maybe you can get more information about this kind of method, about the k-nearest neighbor method. But basically what it does is it takes the prediction and makes the nearest data that it has. It, it looks for that concordance between another data and makes predictions based on that. The second submodel is the prediction with the perceptron, which takes weights. So it is going to make calculations of weights, and through a lot of training examples, it is going to go to update the weights until it has a pretty good prediction of the data. So this is the method of the perceptron. Finally, we have to implement the last model. In this case, we're just implementing the logistic regression, which here is the model, and here is the method that returns the prediction. This is a model that is a lot that is very familiar with us because the first weeks of the Coursera um, course that we are taking is using the regression model a lot. And finally, um, here we have the model, the method that runs the submodels that we have, and finally it gets the stacking method that takes all these predictions and makes you use the regression model or the stack model to combine these predictions and make a new prediction based on those two submodels. Finally, we have here the implementation. All the things that we did here before were only implementing the methods. This is like the main, so we have a seed. We call the data set, we implement it, and finally we evaluate the algorithms and calculate an accuracy, a mean accuracy, which finally is a 76.3 accuracy for all the methods. If you want, you can look at a more detailed explanation in this link. I'm going to share this link here. Here we have also the link for the dataset, which they explain that you have to download it and then change the name specifically to this, to sonar that all data.csv. So that is important that you have it in your environment for the code to run appropriately.